Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello everyone. I'm thrilled to engage with you on the topic of any-to-any multimodal large language models. To begin our discussion, can you provide some insight into the evolution of multimodal AI systems? What advancements have led us to the current state where models can handle diverse types of input and output, such as text, images, and audio?
The evolution of multimodal AI systems can be compared to building a toolbox for a handyman. Initially, these systems only had a few basic tools, like hammers and screwdrivers, which represented just text-based understanding. Over time, as the handyman gained experience and needed to tackle more complex tasks, he started adding new tools, such as wrenches and pliers, which symbolize the inclusion of images, audio, and video. In recent years, advancements in technology have enabled AI models to integrate these various tools effectively. Instead of just understanding words, they learn to recognize and generate content from different types of inputs, like pictures or sounds. This is similar to how a handyman can now use his tools to fix things around the house more efficiently. For example, new techniques allowed AI to connect different types of data by using special parts called adapters. These adapters help the AI understand how to work with images and sounds alongside text, creating a more versatile and capable system. Just as the handyman uses the right tool for each job, these models can now switch between different types of information, making them much more useful in various tasks. Today, systems like NExT-GPT represent the culmination of these efforts, allowing for seamless interaction across multiple modalities. Much like a handyman who can effortlessly switch between tools to get a job done right. The journey continues as researchers aim to add even more tools and capabilities, making AI systems even more comprehensive and universal in their understanding and generation of various forms of content.
That's a fantastic analogy. It truly highlights the progression from basic capabilities to a more integrated, versatile approach in multimodal AI. With that context in mind, could you discuss how NExT-GPT specifically overcomes the limitations of earlier models? What unique features or mechanisms does it employ to enable any-to-any communication across modalities?
NExT-GPT tackles the limitations of earlier models in a few key ways, which can be understood as upgrading from a simple walkie-talkie system to a high-tech smartphone. First, earlier models often connected different types of data using a pipeline approach, where each type of information was processed separately, much like passing a message through several people before it reaches its destination. This method can introduce noise and misunderstandings, as each person might interpret the message differently. In contrast, NExT-GPT employs an end-to-end system, allowing it to process and generate information across various modalities seamlessly. Similar to how a smartphone can handle calls, text messages, and video chats all in one device without losing clarity. Second, NExT-GPT utilizes advanced technology called adapters, which help it align different types of information, like text, images, audio, and video. This is akin to having a universal remote control that can operate multiple devices. These adapters enable the model to understand and generate content in a flexible and integrated manner, bridging the gaps between different types of data much more effectively than before. Additionally, NExT-GPT introduces a new method called modality-switching instruction tuning. Imagine this as teaching a person to switch languages fluidly in a conversation depending on the context. This feature allows NExT-GPT to follow complex instructions and generate high-quality outputs in any combination of modalities, enhancing its ability to respond to user requests in a more human-like way. By combining these unique features, NExT-GPT represents a significant step forward in creating a versatile and powerful AI system capable of handling any mix of inputs and outputs, much like a smartphone that can manage a wide range of communications effortlessly.
That comparison effectively illustrates the advancements in NExT-GPT's capabilities. Could you elaborate on the training process for NExT-GPT, particularly regarding the minimal fine-tuning of parameters? How does adjusting only 1% of certain projection layers contribute to the model's performance and flexibility across multiple modalities?
The training process for NExT-GPT is designed to be efficient and effective much like how a chef can prepare a delicious meal using only a few key ingredients rather than a long list. In this case, adjusting just 1% of certain projection layers during fine-tuning allows the model to focus on making precise improvements without needing extensive resources. Think of the highly performing encoders and decoders as the chef's main tools. By fine-tuning only a small portion of the overall system, it helps keep costs low and simplifies the training process. This is like using a few versatile kitchen tools to create a variety of dishes instead of buying every possible gadget. This minimal adjustment also supports the flexibility of the model. Since it doesn't require a complete overhaul with every new feature or data type, NExT-GPT can easily expand to include more potential modalities in the future, like adding new recipes to the chef's menu without needing an entirely new setup. Additionally, the introduction of a modality-switching instruction tuning method acts like a special technique that allows the chef to switch styles or flavors depending on the needs of a dish. This enhances NExT-GPT's ability to understand and generate content across various modalities, making it more adaptable and capable of handling complex tasks. Overall, by fine-tuning just a small percentage of parameters, NExT-GPT achieves a balance between performance and flexibility, paving the way for a more universal and human-like AI system.
That's a great way to explain the efficiency and adaptability of the training process. Now, could you discuss the significance of the manually curated dataset used for modality switching instruction tuning? How does this dataset enhance NExT-GPT's ability to understand and generate cross-modal content, and what role does quality play in its training?
The manually curated dataset used for modality switching instruction tuning, MOSIT, is crucial for enhancing NExT-GPT's ability to understand and generate content across different modalities. Think of this dataset as a carefully crafted recipe book that provides the right instructions to make a variety of dishes. Just like a recipe with clear steps and high-quality ingredients leads to a delicious meal, a well-structured dataset enables the model to learn effectively. This dataset consists of 5,000 high-quality samples that are designed to cover the complexities and variations of real-world interactions. It allows NExT-GPT to learn how to handle diverse and dynamically changing modalities, similar to how a chef might learn to switch between different cuisines based on the ingredients available or the preferences of the diner. Quality plays a significant role in the dataset's effectiveness. If the instructions in our recipe book are not clear, or if the ingredients are subpar, the final dish will not turn out well. In the same way, high-quality samples in the MOSIT dataset ensure that the model can accurately capture complex user intentions and respond appropriately in multi-turn conversations. This is essential for creating a more human-like interaction, where understanding nuance and context is key. By training with this meticulously curated dataset, NExT-GPT gains sophisticated cross-modal semantic understanding and content generation capabilities. It can effectively bridge the gaps between different types of content, allowing for smoother and more meaningful interactions. Overall, the combination of quality data and careful instruction tuning positions NExT-GPT to perform at a higher level, making it a more versatile and capable AI system.
That's an insightful analogy. The importance of quality data in training AI systems cannot be overstated. As we consider the broader implications of NExT-GPT, what potential applications do you see for this model in real-world scenarios? How could its any-to-any capabilities transform industries or enhance user experiences?
NExT-GPT's any-to-any capabilities open up a world of potential applications across various industries, much like a Swiss Army knife that can tackle many tasks. Here are some ways in which this model could transform real-world scenarios and enhance user experiences. 1. Customer support. Imagine a virtual assistant that can understand and respond to customer inquiries using text, images, and audio. NExT-GPT could provide personalized support by analyzing customer messages, generating helpful visual guides, or even creating audio responses all in real time. This would lead to faster, more effective customer service, improving overall satisfaction. 2. Education. In the classroom, NExT-GPT could serve as a dynamic tutor that adapts to various learning styles. It could explain concepts through text, generate relevant images or videos, and even engage in conversations with students, making learning more interactive and engaging. This versatility could help address individual student needs more effectively. 3. Content creation. For creators in fields like marketing, film, or gaming, NExT-GPT could streamline the content creation process. It could help brainstorm ideas, generate scripts, create visual storyboards, and even produce accompanying audio. This would not only save time but also inspire new creative possibilities. 4. Social media. NExT-GPT could enhance user interaction by generating engaging posts that combine text, images, and videos. For example, it could create a multimodal story that captivates audiences by blending narratives with visuals and sound, increasing engagement on studies. 5. Healthcare. In healthcare settings, this model could assist medical professionals by consolidating patient information, generating studies, or explaining complex medical procedures to patients using easy-to-understand visuals and audio explanations. This could enhance communication and improve patient understanding. 6. Entertainment. In entertainment, NExT-GPT could revolutionize how stories are told. For example, it could create interactive experiences where users switch between reading, watching, and listening to narratives, providing a more immersive experience. Overall, the any-to-any capabilities of NExT-GPT hold the promise of creating more seamless, efficient, and engaging interactions across various domains, ultimately enhancing user experiences and transforming how industries operate.
Those applications truly showcase the transformative potential of NExT-GPT. As we look ahead, what challenges do you foresee in the deployment of such a versatile model? Are there specific technical or ethical considerations that need to be addressed to ensure responsible and effective use of any-to-any multimodal systems?
As we look ahead to the deployment of NExT-GPT and similar versatile models, several challenges, both technical and ethical, need to be addressed to ensure responsible and effective use. 1. Technical challenges. Quality and consistency. While NExT-GPT is designed to generate content across multiple modalities, ensuring the quality and coherence of outputs remains a challenge. Generating meaningful combinations of text, images, audio, and video can sometimes lead to inconsistent results, where the quality may vary significantly between different types of content. Expansion of modalities. As the model aims to include more modalities in the future, such as 3D vision or complex data formats, the technical feasibility of integrating these new inputs and outputs into a cohesive system presents a challenge. Each new modality often requires unique handling and processing techniques. End-to-end updating. The model's reliance on existing pre-trained tools for inference means that without proper end-to-end updating, there could be limits on its ability to accurately interpret complex user instructions and generate content. This can impact its overall performance in real-world applications. 2. Ethical considerations. Content quality and misinformation. There is a risk of generating low-quality or misleading content, often referred to as hallucinations in AI. It is crucial to implement measures that prevent the model from producing harmful or inaccurate information, which could mislead users or cause confusion. Data privacy. The deployment of any AI model must prioritize user privacy, especially when handling personal or sensitive information. Ensuring that data is anonymized and that user consent is obtained when necessary is essential to maintain trust and compliance with regulations. Bias and rest study. Care must be taken to minimize bias in the training dataset to ensure fair and representative outputs. If the data used to train the model reflects biases, the generated content may unintentionally favor or disadvantage certain groups, leading to ethical concerns in how the model is perceived and utilized. In summary, while NExT-GPT presents exciting opportunities for transforming industries and enhancing user experiences, addressing these technical and ethical challenges is vital for its responsible deployment and long-term success.
Your insight into the technical and ethical challenges of deploying NExT-GPT is invaluable. Addressing these issues will be crucial for harnessing its full potential responsibly. As we wrap up our discussion, could you share your thoughts on the future of any-to-any multimodal LLMs? What advancements or innovations do you anticipate will shape the next generation of these models?
The future of any-to-any multimodal large language models, LLMs like NExT-GPT, is poised for exciting advancements, similar to how technology has rapidly evolved over the years. Here are some anticipated trends and innovations that could shape the next generation of these models. 1. Expanded modalities and tasks. One significant advancement will be the inclusion of more modalities beyond text, images, audio, and video. Future models may accommodate complex types like web pages, 3D visual data, and even structured data like tables and heat maps. This broadening of scope will enhance their applicability across diverse industries, allowing for more comprehensive understanding and generation capabilities. 2. Improved multimodal generation strategies. As models evolve, we can expect refined techniques to enhance the quality of generated content across modalities. Innovations in how these models synthesize different types of data will lead to more coherent and contextually relevant outputs, improving user experiences significantly. 3. Integration of various LM variants. Future iterations may incorporate a wider range of LM types and sizes, providing users the ability to select the most suitable model for their specific needs. This would allow for tailored solutions that can better meet the requirements of different applications, from casual use to professional environments. 4. Enhanced interaction and user adaptability. Future models might develop better mechanisms for interpreting user intent and preferences, enabling more personalized interactions. By analyzing user interactions over time, these models could adapt their responses and suggestions, creating a more intuitive and engaging user experience. 5. Ethical and responsible AI frameworks. As these models become more integrated into everyday applications, there will be a strong emphasis on ethical considerations and responsible use. Innovations in monitoring and bias mitigation will be essential to ensure that the outputs are fair and representative, ultimately building trust with users. 6. Real-time processing capabilities. Advancements in computing power may lead to real-time multimodal processing, allowing users to engage with the model seamlessly across various modalities without noticeable delays. This would enhance applications such as live customer support, interactive education, and dynamic content creation. In summary, the future of any-to-any multimodal LLMs looks promising, with potential advancements that deepen their capabilities, broaden their applications, and ensure responsible use. These developments will likely transform how we interact with technology and leverage AI across various sectors, making them even more integral to our daily lives.
Thank you all for joining us today. I hope you found this discussion informative and engaging. We've explored the evolution of any-to-any multimodal language models, focusing on NExT-GPT. We've seen how these models can seamlessly handle diverse modalities, from text to images, audio, and video. NExT-GPT's unique architecture, leveraging adapters and modality-switching instruction tuning, enables efficient and flexible handling of different data types. Its training process balances performance with adaptability. The potential applications of this technology are vast, from enhanced customer support to immersive entertainment experiences. However, we must also consider deployment challenges, such as content quality, expanding modalities, and ethical considerations. The future of any-to-any multimodal LLMs is promising, with advancements in expanded modalities, refined generation strategies, and ethical frameworks. These models have the potential to transform various industries and enhance our daily lives. Thank you again for your participation. We hope you continue to follow these exciting developments in the field of artificial intelligence.